Hey, this is Mr. Morrison, and we're going to talk about polygons today. Polygons are just closed plane figures formed by three or more line segments. So it has to be straight, it can't be curved, and it has to be closed, which means it can't be open. And a regular polygon, it's the same thing as a polygon. It's still a closed plane figure formed by three or more straight line segments. However, the only difference between a regular polygon and just a polygon is that in a regular polygon, everything is the same. All the sides and angles are equal to each other. You can name polygons based upon how many sides they have, and here are a few examples. So a triangle has three sides, three angles. Quadrilateral, like a quad motorcycle, has four. Pentagon, like the building, has five. Hexagon has six. Heptagon has seven. Octagon, like an octopus, has eight. Nonagon has nine, and a decade has 10. If it's something bigger than that, or you don't know it, like 11, 12, you just call it an entagon or a 12agon, something like that. You can also figure out how many degrees are in each of these shapes based on triangles. We already learned yesterday that there are 180 degrees in a triangle, so if you determine how many degrees are in it by breaking it into triangles, you take a shape and kind of see how many triangles fit inside of it. For example, we have a square. So if I start at one side, go to all the other sides, it's important they always start back. Go to here, I have one, two triangles. Since there's two triangles and triangles are 180 degrees, 2 times 180 would be 360 degrees. So there's 360 degrees in this shape, which would be a quadrilateral because it has four sides. This next shape has 1, 2, 3, 4, 5, 6 sides, so we call that a hexagon, six-sided figure. And again, to figure out how many degrees are in it, I would start at one side and just connect to all the other points in it. Just like so. If you notice, I don't even need two of these lines. This line right here and this line I don't need because they're already formed by the shape. But this creates 1, 2, 3, 4 triangles, and there's 180 in each. So before times 180 equals 720 degrees. There'd be 720 degrees in that shape. A common mistake that people make is they just make triangles as many as they can. So they would just kind of go like this with it. This is incorrect because you're making all these extra angles in here. You just care about the angles on the outside of it, not these extra angles you made on the inside. So this would be wrong. You have to make it more just from one point to the other points out. You can't make this extra point in the middle of it out of nowhere. You can only connect it to points you already know. So this one is getting a little bigger. This is 8 sides. And again, I don't really need to connect it there because it's already aligned, so I just go to all of the other spots, and that one's already there, so I get 1, 2, 3, 4, 5, 6. So this would be 6 times 180, and 6 times 180 would be 1080. So this octagon has 1080 degrees inside it, and all the angles added up. So I'm hoping you start to notice a pattern here. So this quadrilateral had 4 sides, and we got 2 triangles out of it. This shape, hexagon, had 6 sides, and we got 4 out of it. This had 8 sides, and we got 6 triangles out of it. So I'm hoping you're noticing that the pattern is, using this formula, 180, how many degrees, n minus 2. The n minus 2 is, hopefully you realize that however many sides there are, 2 less sides is how many triangles there are. 4 sides, 2 triangles. 6 sides, 4 triangles. 8 sides, 6 triangles. So however many sides there are, subtract 2, and that's how many triangles there would be in it. 180 times the triangles would give you how many degrees are inside of it. And n here equals the number of sides in the shape. So in this example, we could use that formula instead of breaking it up into triangles. So we'd start with 180, n minus 2, n stands for the sides. 1, 2, 3, 4, 5, 6, 7 sides. So it'd be 180, 7 minus 2. So if it's 7 sides, we'd end up with really 7 minus 2, which would give us 5 triangles. So this shape, this pentagon, would have 900 degrees. Not pentagon, heptagon, sorry. 5. I messed up. You get what I'm saying. So that's how you figure out how many degrees are in a polygon and classify polygons. Please take the quiz on the right. Good luck, and I'll see you guys tomorrow.